Bismillah Rahman Rahim. Let's get started. So, this is the first lecture on mathematical modeling. I am Samir Rahman, and in this lecture, we will talk about the basic concepts of modeling. And before going into the details of definition related to modeling and mathematical modeling, it's important to talk about system because when we talk about modeling, so modeling is related to system. We take some real world system and we try to represent that system in an abstract way, and that representation is called modeling. So before going into the details of modeling, we will understand what is system. Okay, so a system is a collection of elements or components that are optimized for a common purpose. So a system is a collection of elements or components. It's a collection of elements or components that are organized for common purpose. Okay, and we can also define it as a set of detailed methods, procedure, and routines created to carry out a specific activity, perform a duty, or solve a problem. A system is a group of interacting or interrelated entities that form a unified whole. So here, a system is a group of interacting or interrelated entities. There will be different entities, and they will be interrelated, and they will perform some specific task, and those different components which combined form a unified whole, or they form one system. We can also define system as a set of things working together as part of a mechanism or an interconnecting network. So this is the same definition which we already done in the previous point. Or we can also define a system as a set of principle or procedure according to which something is done in organized scheme or method. Okay, so the system can be defined as a combination of different elements that perform some specific task. Okay, so next we will define model. So a model is a simplified representation of a system. In the previous slide, we talked about a system, that a system is actually a combination of interrelated components that when combined perform some specific task. Or we can also define a system in which there are some components. Each component performs some subtask, and when all these subtasks are combined, so we get a one whole task. So that is the definition of a system. And now we come to the model. So a model is a representation, a simplified representation. This is important, that model will be a simplified representation of a system. A model is a simplified representation of a system or process or theory intended to enhance our ability to understand, predict, and possibly control the behavior of a system. Now this is important, that the model is actually a representation of a system. This is not a system, it is a representation of a system. And why do we represent a system? So we represent a system to understand a system, that is how the system works. So we try to model a system so that we understand its working mechanism, and predict and possibly control the behavior of a system. When we understand the system, then we are able to predict its behavior. That, let's say, we have a system, so we can predict that how it is behaving now, and what will be its behavior in future. So the when we understand the model, then we are able to predict the system and then possibly control the behavior of a system. When we understand the system, then we can also control its behavior. So for these things, it's important to model the system. So, understanding is necessary to change, to preserve, or just to know and explain the behavior of a system. This is important to understand a system and to manipulate its behavior. Okay, so understanding is necessary. Understanding is necessary means that understanding of a system is necessary to change, to preserve, or just to know and explain the behavior of a system. Okay. Okay, so model may have different views. Okay, now for example, for children, clay models, building blocks, different games for different purposes. So the clay model, they are actually represented the human beings. The human beings are the actual system, and the clay models are the models. Now building blocks, so building blocks are also representing some system, different games for different purposes. Fashion models for an advertising agency. So fashion models actually represents, for example, when there are some advertisement about shoes or clothes or whatever it may be. So these fashion models actually model the main system, and the main system are the clients. For example, how these items will look when the clients wear those items, let's say clothes or shoes or whatever it may be. So these represents the different, these fashion models are actually represent the clients. In engineering and science, we use mathematical models, and these mathematical models represent some systems. Architect, architects and defense people, so they use physical models. For example, in defense, they represent a city through some maps. Okay, now observation. So model is only a representation of a system and not a system itself. This is important to know, that model is just a simple representation of a system, and this is not a model itself. It can't satisfy characteristic of a real world system. This is also important to know, that the models are the simplified version. Now for example, when we take a globe, a world globe, so this world globe is represent the world, but this is not the actual representation. This is the simplified form of the world, the globe map. Globe means the map. So this represent the world, but this is not the actual representation. Okay, it doesn't satisfy the characteristics. Okay, models are artificial, they don't exist freely in nature, and they tend to be abstract. This is important: abstract, general, and very often details are collapsed many to one. We try to reduce the details. If there are, let's say, 100 characteristics, so in model we represent those 100 characteristics by sometimes a single characteristics. So this means that they tend to be abstract, and we try that the details are minimized. Okay, example: road map is only a man-made model of the road networks of a region. We have road maps, so these road maps are models of the actual road networks. An ordinary photograph is simply an analog representation of a scene or an object, and not a real thing itself. When we take a picture of a scene, so this picture is a model of that scene. That is not okay. So an ordinary photograph is simply an analog representation of a scene or an object, and not real thing itself. This image picture is actually a representation of a scene. Now Types of model. So broadly, models are classified into three categories: physical models, symbolic models, and mental models. We have these three different types of model: physical models, symbolic models, and mental model. So the physical models are made of tangible components. For example, house model, clay model of a man, human model in shop, statue of a great personality. So all these are physical models. Now symbolic models. So mathematical, some symbolic or logical relations, maps, graphs, words, pictures. These are symbolic models. For example, equations. F is equal to ma. So this equation is actually representing the physical phenomena. Various types of diagrams, system flow diagram, use cases, Venn diagram, flow charts, etc. All these are symbolic models of a real world object. And mental model, so this exists only in the minds of individual. For example, ideology, decision making, imagination of an event. So these are mental model. Okay. Now, physical models. We start with physical model. Physical model can be static or dynamic. Static are scale or imitation. These are copies. Okay. So scale, non-operational replica of a real system. Clay, wax model, bridges, cars, ships. These are the scale models. Okay. And imitation, these are not very accurate but easy to understand. For example, puppets, cartoons, dolls, dummies used in film, etc. These are imitation. Okay. So when we talk about the static model, so static models are of two types. It can be a scale or imitation. Scale is the representation, but this is not non-operational replica. Okay. Non-operational means that it doesn't work. Okay. And these are a static model, non-operational static model. And imitation, these are non-operational copies of the original systems or objects. Now physical model. So physical model can be dynamic. Okay. And in a dynamic, these will be analog or prototype. So when we talk about analog, so we use one type of physical model to represent another type. Analog means similarity. For example, mercury used in thermometer to measure temperature, animal use for testing a medicine. These are analog models. And prototype, so this type of model is functional replica of a real system. Now this is important. Okay. Prototype or functional replica, functional copies of a real system. For example, prototypes of chemical reactors, functional rail engine, robot or machine models. These are functional. Prototype are functional models. Okay. Symbolic models. So in symbolic models, there are two types. One is mathematical models and second is non-mathematical model. So in non-mathematical models, we have linguistic models, graphical models, and schematic models. Okay. So in listing linguistic models, we have verbal or written description of events, experiences, scenes, dreams, ideology, or code of practices. And in graphical models, painting, picture, graphs, drawings, etc. Schematic models, layout, network diagram, flow chart, maps, circuits, etc. So these are the types of non-mathematical models. Okay. Symbolic models, so these are easier to understand and cheaper than physical model. These can be mathematical or non-mathematical. In non-mathematical model, we have linguistic graphical schemes. Uh, and in linguistic, these are description of an event, verbal or written or seen or experience, ideology, dreams, etc. Graphical painting, picture graph. These are already discussed in the previous slide. These are just the extension of the previous slide. And now we come to mathematical models, which is actually the topic of our interest. So mathematical models are of two types: dynamic models and static models. So in dynamic model we have analytical models and numeric models. We will discuss the details of these. And then static models, so numerical models and analytical models. We can represent dynamic models through analytical model and numeric model, and we can also represent static model through numeric model or analytical model. And these numeric models are used for simulation. So simulation is represented through numeric models. Okay, now mental models. So these heuristic models only exist in minds. These are fuzzy, imprecise, and difficult to communicate. For example, ability to understand and perform mental arithmetic, to express ideas in mind, communication skill, to write an efficient computer program. So these are mental models. Okay, other models. So deterministic versus stochastic, linear versus non-linear. Now, in deterministic model, these are for specific input, a model is able to provide predictable solutions. In deterministic model, we know that for a given input, we will get that output, and this is like constant for that input. It will always give the same output. In stochastic model, for a specific input, a model may produce unpredictable output. Okay, so these are stochastic model. In stochastic models, we can have, at one time we may have one output per a given input, and at another time instance we can have a different output for that same input. So these are called stochastic models. Now a linear model, so this is the linear relationship exists between input and output, prices versus quality of petrol at filling station. We will discuss the details of these models in our future lectures. Okay, thank you.